The box of a fan states that the fan consumes 25 watts of electric power and that it can discharge from a ventilated room at a rate of 1.2 kilograms per second and a discharge velocity of 7 meters per second. Is this claim true? Try pausing here to try to solve this problem yourself before watching the solution. This is the first example for the first law of thermodynamics 12-minute lecture video. The links to that video, the other examples on this topic, and the other lectures of the thermo course are found in the description below. If we select a control volume just around the fan itself, we see that it is receiving a rate of work, or work in, as a rate, W in dot. In the most ideal scenario, the drag or friction between the blades and the air is not generating any heat lost to the existing air. Also ideally, the electric motor itself is not producing any heat either. The conservation of energy equation, written as rates of energy, meaning variables with a dot, would only have rate of work coming in and the rate of change in kinetic energy. Everything else is assumed to be negligible in the ideal scenario. The exiting kinetic energy rate would be equal to the mass flow times the specific kinetic energy due to the exit velocity. The inlet velocity can be assumed to be zero. We have two options here. We can either substitute the mass flow and the velocity information to find that the necessary work rate in would be 29.4 watts for the fan to reach the discharge claims, contradicting the electric power claim, or two, solve for the velocity and substitute the mass flow and wattage information to know that the 25 watts would only allow the discharge of air to happen at 6.45 meters per second, also contradicting the given information. We could also solve for m dot and find that the value is lower than the spec'd 1.2 kilograms per second. In any case, the claim in the box is false, as even with ideal conditions, the conservation of energy does not occur. If we were to add heat rate out, as power that is lost from our control volume in the form of thermal energy due to friction, the differences would be even larger. If you want to check out the other examples for this same topic, the main lecture video, or other lectures of the thermo course and other engineering courses, make sure to check out the links in the description below. Thanks for watching.